Hey guys, welcome to Coding Spot. In today's tutorial, we'll be coding an unbeatable AI to play against in Tic Tac Toe. It's not clickbait, it's literally unbeatable, and the best result you'll manage to get, it's gonna be a draw. So yeah, it's super cool. I'm super excited about it. You guys really like the classic Tic Tac Toe tutorial, and you ask a lot for this AI version. So yeah, it's not a requirement to see my classic Tic Tac Toe tutorial. But if it's your first time coding or using Pygame or Python, I strongly recommend you to see that tutorial first, as it's a super detailed and super beginner friendly tutorial. However, you can just watch this one, as we're gonna be coding this game from scratch, and the code it's gonna be totally different as the one I used on the other tutorial. So yeah, I'm gonna show you the final version of the game. Here we have our screen, and we're gonna be able to play against the AI, obviously, and also against another human. So we have two game modes. I'm gonna show you the AI game mode. So I'm gonna choose a square, and the AI selects another square. And we get a message printed on console which says AI has chosen to mark the square in position 1,1 with an evaluation of 0. So we are gonna go into detail of what this evaluation means throughout the tutorial. So yeah, I'm gonna choose another square, and as you can see, AI is gonna block me and it's not gonna let me win. And if I choose this square, the AI, it's obviously gonna win. And as you can see, the message, the evaluation of the AI now goes to -1. So yeah, as I told you, we're gonna go into detail of this evaluation function we have here. Also, we can restart the game, so let me restart it, and we can play against another person. So I'm gonna change the game mode. I'm doing all these through the keyboard, so don't worry if you don't, well, we don't have buttons or anything to change the game mode here, but I'm doing it through the keyboard. So yeah, now I can play against a human or another person, a family, a friend, whatever you want. We have a tie here. I added another game mode, or well, it's actually part of the AI game mode, but it's an random AI. So I'm gonna put it, and as you can see, AI has chosen a random position. As we get the message, AI has chosen to mark the square in position 1,2 with an evaluation of random. So this is the random game mode, and as you can see, okay, in this case, the AI blocked me, but it's totally random. As you can see, in this case, it didn't block me, and I was able to win. So yeah, we have three game modes: AI but random, and PvP, or player versus player. So yeah, I think it's pretty cool. This is gonna be the code structure. This is the structure of our code. We're gonna use classes and objects. We're gonna be coding a game class, an AI class, and a board class. So if you haven't worked with classes, don't worry. I'm gonna try my best to explain, and you'll see it's not that hard as it looks. So yeah, I hope you liked the tutorial, and let's start coding the Unbeatable AI. Okay, so go ahead and open your project folder. For this tutorial, I'm using Visual Studio Code as my text editor. I know I've been using Sublime Text for my other tutorials, but as you know, it's pretty much the same. So you can, if you have Sublime installed, well, it will work fine with Sublime. Okay, so we're gonna start by creating a new Python file. I'm gonna name it tictactoe.py. So we have our Python file, and we're gonna start by importing two models. The first one is gonna be the sys model. This is gonna help us to quit the application, and we're gonna import Pygame, obviously. So if it's your first time using Pygame, I just want you to know that these first lines of code are always the same, so don't worry if you don't understand the code right here. So the first line of code that we want to type is pygame.init. We want to initialize our Pygame model. Then we want to create our screen, so I'm going to call it screen equals pygame.display dot set mode, and inside of these brackets we're gonna pass a width and the height that I'm gonna create right now. So I'm gonna create a new file. I'm gonna name it constants.py, and we're gonna save our constants right here. So this is pretty useful, as we're gonna need these values throughout basically all the code. So we can access them from this file. So let's create our width and height variables. I'm gonna set it equal to 600. So we are gonna have a screen of 600 by 600. And we need to import these constants file for it to work properly. So go ahead and type from constants import, and we're gonna type this asterisk, which means that we want to import all of the things on this file. Okay, so once we have the screen, we want to set the caption, so it will be something like pygame.display.set caption. I'm gonna name it Tic Tac Toe AI. This is the caption of the screen, so it really doesn't matter what you put here. What else? Okay, we're gonna create our main method. So go ahead and type def main. I'm gonna pass for now, and we're gonna call it down here. Let me put this. So this is our entry point. This is where the file is gonna start executing. So yeah, inside this main function, we're gonna code something called the main loop. So if you've worked with Pygame before, well, you probably know what I'm talking about. But if it's your first time using Pygame, remember these first lines of code are always the same. So we're gonna type while true, and we're gonna put for event in Pygame dot event dot get, and we're gonna type if event dot type equals Pygame dot quit. We're gonna type Pygame dot quit and sys dot exit. So yeah, this is pretty much the code needed to display our screen. So I'm gonna go ahead and save and run the file. And as you can see, we have our screen, which is a screen of 600 by 600 pixels. So let's go ahead and add some design to our screen. So yeah, we need a kind of background for our screen. So let me go to our constants file. I'm gonna add a new color here. So I'm gonna put a comment here. So below these, we're gonna save all of our colors. So the first color is gonna be the background. So background color, and it's gonna be, obviously you can use, well, whatever color you want, but I really like this design, so I'm gonna go with this one. So this color is 28, 170, and 156. This is RGB format for those of you who, well, don't know. So it's basically a way to define colors, right? Okay, so we have our background color. We can go back to our Tic Tac Toe file, and we can type the following. So down here, let me edit this comment. I'm gonna put Pygame setup, and we're gonna type screen. So this same screen, it has to be the same name that you put here. So screen.fill, and we're gonna put our background color. And inside of our main loop, right, but outside of this for loop, so I'm gonna get into detail of this for loop later in the video. Yeah, but for now, let's just ignore it. And outside of this for loop, but inside of the while, so right here, we want to type pygame.display update. So like this. I'm gonna save and run the file, and you'll see our screen has a background color now. So it's pretty cool. I like this design, I like this color, but you can use obviously any color you want. So yeah, by the way, I forgot mentioning something. If you don't have Pygame installed on your computer, you may be having some problems. So first of all, make sure to have Pygame installed. I have a video explaining how to install Pygame. It's super detailed. You can find it on the description below. So make sure you have Pygame installed first. Okay, so now that we have our background, we're gonna go ahead and draw the lines, the Tic Tac Toe game lines. So by lines, I mean like the lines that are dividing each square from one another. So let's go ahead and create the new class. So go ahead and type class game. We're gonna create our init method. So remember, it has to be underscore underscore init underscore underscore. We're gonna pass for now. This init method, for those of you who don't know, like this is gonna be called each time we create a game object. So in this case, we're just creating one game that it's gonna be, well, our Tic Tac Toe. But yeah, let's say that we are creating lots of games. So this init method, it's gonna be called each time we create a new game object. So I hope I'm being clear with that concept. So okay, we are going to create a new method inside the game class. We're gonna call it show lines. We're gonna receive self as parameter. So okay, before we code this method, I want to add some more constants here. So we're gonna add rows. It's gonna be 3. Calls is gonna be 3. We're gonna add a new constant called square size. This is super useful, you'll see. And square size, it's gonna be equal to either width or height divided by either rows or calls, or you can just put 200 if you are using my same dimensions. But I will put width divided by rows, by calls. Okay, we have that. We're gonna create also a line color. So yeah, the same as this color, you can use whatever color you want, but in my case, I'm gonna use 23, 145, and 135. Okay, now that we have those constants, I think we can go ahead and code this method. So okay, there are gonna be 4 lines. There are gonna be some vertical lines and some horizontal lines. So let's start with the vertical ones. So go ahead and type pygame.draw.line. The first parameter is gonna be a surface. So we're gonna pass screen. Second parameter is gonna be color. So we're gonna put line color. So next parameter is gonna be a starting position. So for the first vertical line, we wanna start at the x-axis of square size, comma 0. This is the y-axis. And the ending position of the first vertical line is going to be square size, comma height. And the last parameter is going to be the width. We're going to use a line width that we didn't create it. So let's go ahead and create it here. Let me put this here. I'm going to put line width. We're going to set it equal to, let's see, I think 15 is okay. Okay, so I'm going to call this show lines method inside our init method. So go ahead and type self.showLines. Okay, so we're missing the object. So we need to create the object, because remember, once we create the object, the init method is going to be called. Hence, we're going to call show lines. So I'm going to create the game object here. I'm going to put game equals game. So this is the object and this is the class. So again, when we create this game, init method is going to be called, hence show lines is going to be called. So I'm going to run the file for you to see the first vertical line. So as you can see, we have the first line. So let's go ahead and code the other 3 lines. So I'm going to paste this here. Okay, so the second vertical one is going to start, I mean, the screen is the same, line color is the same for all. X-axis, we're going to start at width, minus the square size. Y-axis, we want to start at 0. We're going to end at the width, minus square size, same X-axis. And we're gonna end at the height. Yeah. Now horizontal lines. We want to start 0 on the x-axis. Square size for the first one. Now the ending position is gonna be, let me think. It will be width, comma square size. Same line width. And the other one, the second horizontal line, it's gonna start at position 0, comma height minus square size, and the ending position is gonna be width, comma height minus a square size. So I think this is correct. I actually don't know. I'm gonna run the file to see. Okay, yeah, perfect. We have our background ready. Like we have our graphic board ready to use. Okay, so let's now create a board class. By the way, the game class, it's not finished, but we are gonna be coding it throughout the video. I'm gonna create a new attribute on the game class. I'm gonna call it board. So we're creating our board now. This is like the console board. We had the graphic one, which actually is not gonna help us with the logic. We're gonna create one console board. You'll see what I mean. So this is going to be a board class. So I'm gonna go ahead and create it on top of the game class. Create our init method. And for now, I'm going to create just one attribute. I'm gonna call it squares. And this is going to be a two-dimensional array, full of zeros. You'll see what I'm talking about. So to create this, we need to import a new module, which is going to be NumPy. So go ahead and type import NumPy as MP. I'm pretty sure NumPy comes with Python, so you don't have to install it. So okay, self.squares is gonna be nmp.zeros. So we're accessing our NumPy model .zeros, and inside we're gonna send as parameter a tuple with rows, comma columns. I'm gonna print this. So print.self.squares for you to see. As we're creating the board here, this is going to call the init method, so we don't have to call it. So yeah, I'm gonna run the file. So as you can see, we have our console board right here. So it's full of zeros, which represent an empty square. Awesome. So yeah, we're gonna have plenty of functions inside of our board class. But for now, I want to code one useful function that is gonna be, we're gonna name it mark square. We're gonna receive self, we're gonna receive a call, a call and a player. So let me pass for now. So this player, we're gonna have two players, player number 1 and player number 2. So if player number 1 marks a square, that square is no longer going to be 0, but it's going to be the number of the player. So it's going to be either 1 or 2. So what I want to do inside of our mark square function is do self.squares in the position row, in the position call, equal player. Now, if we call this mark square function with 1, 1 and with the player number 2, and then we print our self.squares. By the way, this is testing, so yeah, we are not going to this is not part of the code, we're just testing here. I'm gonna run the file, and as you can see, we managed to mark the square at the middle. So yeah, it's in the middle because arrays start at 0. So 1 will be the second column and the second row. Okay, so hope that's clear. Now that we have our mark square function, we're going to create inside of our game class a new attribute that we're gonna call player, and we're gonna set it equal to 1. So this is basically telling us which player is the one, or which is the next player to mark a square. Yeah. Okay, so let's go to our main loop, and we're gonna do the following. We're gonna add an event. So I'm going to explain a little bit this for loop. We're just looping through all of the events on Pygame events. By event, I mean, well, I don't know, an event can be either if you quit the application, that's an event, or either if you click the screen, that's an event. If you press a key, that's an event, and so on. So we're gonna check if event dot type equals Pygame dot mouse bottom down. So we're checking if someone, or us, if we are clicking the screen. Okay, so inside of this, I'm gonna do the following. I'm gonna print something called event.pause for you to see what's that. So we have our screen. I'm gonna click right here, and as you can see, we're getting some coordinates printed on the console. Now those coordinates are the coordinates where our click was located. So we don't want to have those coordinates, because I don't know if you saw. I'm gonna do it again. Let me print again the event.pause. So as you can see, there are huge numbers because they are in pixels. So, we wanna work with the rows and calls. So how do we do that? So we're gonna let pause equal event.pause, and we're gonna put row equals pause in the position 1, because this is the y-axis, and the row will represent like the y-axis of our board. This is gonna be divided square size. Now call is gonna be equal to pause the position 0, so the x-axis, divided by square size. That way, let me print row comma call. I'll see what I mean. So as you can see, we we printed 0, 0, 1, 0, 1, 0, 2, 1, 0, 1, 1, and so on, so on. So we managed to convert from coordinates, from pixels, to rows and columns. So this is pretty useful. Why? Because now we can do the following. We can check, well, not check, but we can mark a square. So we can put game.board. So remember, this is our game object, and our game object has a board object. So game.board dot mark square in the position row, comma call, and let's say with player number 1. And we want to print, I'm gonna print game.board.squares for you to see what happens. Okay, let's see. I click the middle, and as you can see, we mark it. So yeah, it's working. We are from the graphic board, we are sending information to our console board. So that's what we want. Now, before we continue coding, I want to do something. Before this while, or before the main loop, let me put a comment actually here, telling this is our main loop. So before that, I'm gonna save into a variable called board our game.board. Why? Because I don't want to be typing game.board each time we want to access our board. So it's much simpler to have, well, just a board variable. So we can erase this. So okay, we want to mark it, but we want to mark it just if that square, well, is empty, right? So we're gonna create a new function here. I'm gonna call it def empty square. We're gonna receive row, call, and no more. And how do we know if a square is empty? Well, pretty simple. We want to check if the squares on the position row and on the position call is actually equal to 0. And we're gonna return this. Okay, there's an error. Oh, okay, we're missing self as parameter. Yeah. So self.squares in row call equals 0. We want to return this. If this is true, so if this is 0, this is gonna return true. And well, if it's not 0, it means it's not empty. So right here, we want to check if board.empty square in row comma call, well, then we want to mark it. So now if I click, okay, I'm actually not printing it, so you can't see it. Let me print it. It will be board.squares. So now if I click in the middle, it will print it. Now if I click it again, I already click it, but we didn't print it. Why? Because we didn't enter this if statement, because the square wasn't empty. So this is useful, and this is what we want to do, like mark the square once it's clicked. Okay, what else do we want to do? We want to somehow change the player that is marking the square, right? So let's create a new method on our game class, and we're gonna call it change player, or not change player, but next player, or next turn. I'm gonna call it next turn. We're gonna receive self. And this is pretty simple. We're gonna do self.player is gonna be equal now to the self.player model2 plus 1. Let me explain this code. This is gonna give us a reminder between self.player, so the integer of self.player, and 2. So when self.player is 1, model2 is gonna give us 1 plus 1. We're changing it to 2. When it's a 2, well, 2 model 2, it's gonna be a 0 because there is no remainder. We add 1. Now we change to the first player. So we can change players in a pretty simple one line of code. Okay, so once we mark it, we wanna put game.next turn, and that's it. So now instead of marking the square always with a 1, we want to mark it with the game.player. Makes sense. So let me print the board.squares for you to see what's going on. So I'm gonna click the first square. As you can see, it's player 1, so it marked it with a 1. I'm gonna now click the second one. Now it's marking it with a 2. So that's what we want. Pretty cool. Okay, now it comes another big function that we need to code. I'm gonna call it, so we're gonna do this before this game.next turn. So go ahead and type right here game.draw fig in a row, in a call, and we're gonna pass, let me think if we need to pass the player. I'm not sure. Oh yeah, I think we need, yeah, game.player. Actually, we don't have to pass it. You'll see why. Okay, so we need to create this new function, draw fig. It's gonna be responsible of drawing the figure once it's clicked. So we're sending information. I want you to see how we're connecting the graphic board to the console board. So we're sending information from the console board to the graphic one, and like the graphic one is displaying the information like in a pretty good looking way, basically. So okay, let's go ahead and create this function draw fig inside of our game class. So I'm gonna put it right here, draw fig. We want to receive self, row, and call. Now I'm gonna code this game the following. Player number 1 is gonna be the one putting crosses, and player number 2 is gonna be the one putting circles. For you to know, you can change these. I'm gonna go with this setup. Okay. Okay, let's code our function. So we can basically type if game.player, I'm sorry, if self.player, because we are in the self class. if self.player equals 1, we want to draw cross. I'm gonna pass for now. Now elif self.player equals 2. We want to draw a circle and we want to pass. Okay, so that's why I was telling you that we didn't need the player parameter, because we have access to our self.player. So instead of getting the parameter, we can just access our self.player attribute. Okay, let's start by drawing this circle, which is actually a little bit easier than the cross. So circle is gonna be the following. We're gonna type Pygame .draw.circle. We need a surface, that will be screen. We need a color, that will be we need to create it, so circ color. We need a center, I'm gonna call it center. We need to create that also. We want a radius, we want to create that also, and we have a width, circ width, and that's it. So I'm gonna create the center here. For now, I'm gonna let it equal to these brackets, empty brackets, and I'm gonna go ahead and code these constants. So circ color, radius, and circ width. So let's go ahead and put circ color, and I'm gonna go with the following one: 239, 231, and 200. Also, our circ width, it's gonna be equal to 15 also. And what else did we need? The radius, yeah. So radius is gonna be equal to the square size divided by 4. These are, like, I don't want you to get lost with these. Like, these are just values that, well, I play with them, and it seemed to work for me, you know. So you can put any value you want here. It doesn't have to be square size divided by 4. Okay, we have the constants ready, and we now want to create the center position. So center position is going to be the following. Will be our call that we send by parameter times square size plus square size divided by 2. That's the x-axis. For the y, we're gonna do the same, but with the row. Plus square size divided by 2. So this will do it. So let me, okay, I'm gonna test it. So the first click is gonna be the cross, so we're not gonna see it. Okay, that's the first one. Now the second one, we should see it. Awesome, we have it. So as you can see, I'm able to draw, well, only circles. Awesome. Now let's go ahead and code the cross. This is a little bit more complicated, as it needs an ascending line and a descending line. Okay, so we're gonna start with the descending line. So we're gonna go ahead and type pygame.draw.line. Surface is gonna be screen. Color is gonna be cross color. We wanna create this. Next param is gonna be the starting position. So I'm actually gonna call it start this of descending and end this. These two params are gonna be positions, and the last parameter is gonna be the width. So it will be cross width. Let's go ahead and create those constants. So cross color, it's gonna be 66, 66, and 66. And the cross width, I think I was using 20. Yeah, I was using 20 here. Yeah. Okay, now we need to create the starting descending and ending, or end descending. So start descending is going to be equal to a position. So okay, this is a descending line. We want to do it. Let me think about it. Okay, so first of all, I'm going to create a new constant. I'm going to call it offset. You'll see what offset is once we draw the cross. So start descending is going to be offset. No, I'm sorry. It's going to be column times square size plus offset, comma, the y is going to be, I think it's going to be the same, row times square size plus offset. This is actually a little bit hard to code, like by just imagine it. It's pretty, like, it's easier for me when I have a paper, or you can draw the line, or you can like visualize it. So don't worry if it's a little bit confusing for you, but if you pass this to a paper, that would be pretty obvious. Okay, let's code now the end descending position. We want to start, let me think, no, not a start, but the x-axis is gonna be row, oh wait, call times, this is hard to imagine. Let me see, starting descending, I think this will be square size plus square size minus offset. I think it's like this, and the y is gonna end, I think it's the same, so row times square size, not sure, plus square size minus offset. I'm gonna run the file. I'm gonna test this method, and you'll see what offset is in a while. So this should work. Awesome. So as you can see, we have our descending line, and yeah, by offset I just mean this distance between the beginning or the ending of the line with the board line. So that is the offset that I was referring to. Okay, let's now code our ascending line. I'm gonna copy and paste because it should be pretty similar. Okay, so let's change these names from, so it will be start ascending, and this will be end ascending. Okay, so we started ascending. X-axis, it's going to be column times square size plus offset. I think it's the same x-axis. The y is gonna be row times square size plus square size minus offset. The ending x is going to be, let me think, col times square size plus square. I think it's the same. And the y is going to be just row times square size plus offset. I'm not sure, so let's test it. Oh my god, yeah, we have it. So yeah, if you are getting confused with all these values, I recommend you to like literally take a paper, draw the Pygame like screen. Remember, Pygame coordinates work well different. X-axis increase to the right, but y-axis increase downwards. And like literally try to visualize these values. It's much easier. So yeah, as you can see, we managed to well paint or draw our figures. So we have like a pretty good chunk of our code now. Okay, so we are actually closer and closer to start coding our AI. Before we start coding the Unbeatable AI, I want to add some more useful functions to our board class. These functions, we're gonna use them inside of our algorithm, AI algorithm. So I just want to complete this class. Well, not complete, but I mean leave it with a good amount of useful functions for us to work when we're doing the algorithm, the AI algorithm. So okay, I'm gonna start by adding two attributes. First one is gonna be called empty squares. This is gonna be well, when we initialize it, when we create our board, this is gonna be equal to the self.squares, and it's basically a list. So let me comment this: a list of squares, of empty squares. So At the beginning, obviously, the empty squares are going to be, well, all the squares. So that's why we put it with, well, equal to self.squares. Now we're going to add another attribute that is going to be marked squares. So this is different from this because this is not going to be a list. This is going to be a number. So we're going to set it equal to 0. And you'll see why in just a moment. So let's okay, so each time we mark a square, we want to increase that marked square by 1. This will help us, or this will help us know when our board is full. So we can literally create a new function called isFull. We're gonna put self as parameter, and we want to return if the self dot marked squares is actually equal to 9. So super simple, the isFull function. Likewise, we're gonna do a isEmpty function that it's pretty much the same. So return self dot marked squares equals 0. Let me think, what other function do we need? Okay, we're gonna code another function that I'm gonna call getEmpty. So def getEmpty squares. We're gonna receive just self as parameter, and for this, I mean, there are many ways you can do this. Like, you literally can add an attribute to the class, call it I don't know, yeah, the empty squares could be the one, and just return that attribute. The problem with that is that when you mark a square, you will need to delete that from the empty square list. I don't know if I'm being clear. I'm gonna make this function much more simpler, and I'm just gonna do the following. So create a new variable we called empty squares. We're gonna set it equal to an empty list, and we're just gonna go ahead and do the classic double for loop. So for row, in range rows, and for call, in range calls. Classic double for loop, and we just want to check if self dot empty square. So this function, we're gonna call this function in row comma call. So if this is true, we can append. So empty squares dot append, and we want to append the row and call, and that's it. We want to return that list at the end, return empty squares. So yeah, as I told you, there is another way to do this that I think it's a little bit more, well, not complex, but a little bit more confusing than this one. So I'm just going with this one. Okay, let me think, what else do we need? Okay, so all of these functions, we're not gonna use them now, but as I told you, we're gonna use them as soon as we start coding our AI algorithm, which is called the Minimax. I think many of you have heard of the Minimax algorithm. So yeah, we're gonna code one more function. Let's see, I'm gonna code it right here, actually on top. I'm gonna call it final state. We're gonna receive self and the function. So let me put a comment here, because this function is gonna be huge. So I want you to understand what this function does. So we're gonna return 0 if there is no win yet. This doesn't mean that we have a draw, right? This means that there is no win, okay? If we have a draw, we'll need to use the isFull function and just check if there's no winner when our board is full. So I just want to make that clear, like returning 0, it's that there is no win, but it doesn't mean that there is a draw, okay? We're gonna return 1 if player 1 wins, and we want to return 2 if player 2 wins. So yeah, this function is going to be responsible of this. This function is also going to be responsible of actually drawing the wins when we have a win. But as I told you, we're going to leave that for the end. I want to code first the AI. So, okay, let's start by, but we want to check this. This is useful for our AI, so we need to check it. So let's start with vertical wins. We're gonna do the following. So for vertical wins, if you think about it, we just wanna loop through all the columns, yeah. So it will be something like for call, in range calls, and we wanna see if self.squares in the position. So the first one is the row. So in the row 0. And column call is actually equal to, I'm gonna copy this to the one to the square on row 1, but same column. That way we are checking the vertical, and this is equal to the last row, so the second one, same column, but this is not equal to 0. Why? Because we don't want to, well, the idea is to check a win, right? If we don't put this last line of code, well, it's gonna check empty columns, empty vertical like wins, but they are not gonna be wins because they are empty, you know. Okay, so if that is true, we want to return any of these squares. So it could be this one or this one or this one. Why? Because these are numbers, and these are not any numbers. These are actually the player number. So I'm gonna give you an example. If player 1 wins vertically, this is going to be for, I don't know, for let's say column number 1, this is gonna be 1 equals 1 equals 1, but it's not equal to 0, so there's a win. Therefore, we want to return 1. Why? Because the function tells us that we want to return 1 if player 1 wins. Okay, so that's vertical. I'm gonna code the horizontal wins, which is actually the same, but we need to change calls for rows. And here we want to put row, and in call we want to put 0. I'm gonna copy this, paste it here and paste it here, change the column to 1, change the column to 2, and we want to return, well, any of those. Same logic as the one of the vertical win check. Okay, so right here we're checking all vertical possible wins and all horizontal possible wins. Now we're missing diagonals, right? So let's start with the descending diagonal. This one is super easy. We just need to check if I paste this thing here, but we want to check if squares in 0, 0 equals squares in 1, 1 and squares in 2, 2. And as always, this is not equal to 0. We want to return any of these. I'm gonna go with this one, 1, 1. Why? Because this square, which is the middle one, it's gonna be a common square between both diagonals. So yeah, I just want to return that one. You can return like whatever you want from this. Okay, ascending diagonal. It's gonna be pretty similar. I'm gonna copy that. I'm gonna paste it. Instead of 0, 0, we're gonna go with 2, 0. 1, 1. As I told you, it's gonna be like the common square, and the ending thing it's 0, 2. Yeah. Now, if there's no win, we should return a 0, right? So right here, return 0. Why? Because the function says that we need to return. I mean, says is that I'm saying, but yeah, I like to put it in those terms. So it returns 0 if there is no win yet. So there we have it. So let me put a comment actually. No win yet. Okay, so final state function. This is gonna be super useful when we code our AI. So yeah, I think we have all functions from our board class. Okay, so I hope those functions are clear. We are not using them. Well, we are using some like mark square, but we're gonna, as I told you, we're gonna use them when we code the AI. Okay, so now I'm gonna add some things to our game class, like pretty small things, to start coding our AI. So okay, first of all, let me add a comment here which says self.ai equals a new AI. We're gonna uncomment this when we start coding the AI. We're gonna add something called game mode. So this is the thing that I will mention at the beginning of the video. We can have a game mode of PvP, so player versus player, or AI. So it's PvP or AI, the game mode. We're gonna start with the PvP. What else? We're gonna add a new attribute called running, and this is gonna be equal to true. This is basically if the game is not over. So what I mean with game over is either if a player wins or if there's a draw, like the board is full. So when that happens, we're gonna set these to false, but we're gonna do it later. I think we want to do this after we code the AI. Okay, next turn change. Okay, I think we are ready to. Well, we're missing some functions and some attributes that we're gonna add later, but they are not important for our AI. So I think we can start coding our AI. Yeah. So yeah, guys, I want to be really like detailed explaining the Minimax algorithm. So I'm gonna try explain it first, and then we want to start coding it, because it's gonna be obviously the most challenging part of this tutorial, and it might be a little bit confusing if you haven't worked with the Minimax before. So I'm gonna explain it to you first. Okay, guys, so I'm gonna try my best to explain the Minimax algorithm. I'm gonna show you a step-by-step graphic explanation. So yeah, before I start with the explanation, I want you to have clear two concepts. The first one is gonna be something called the terminal case. This is also called the base case. So in Tic Tac Toe we have 3 terminal cases. The first one is when the player 1 wins. The second one is when player 2 wins. And the third one is when we have a draw. So yeah, I think you can clearly see what a terminal case is. So it's basically when the game is over, right? Now the second concept is gonna be the following. For this example, we're gonna suppose that the circle, so the person that is putting the circle, it's going to minimize. And the person that's putting the X, it's going to maximize. Now this is confusing, I know, but we'll see what I mean with this. So for now, you just need to know that we have some terminal cases, 3 terminal cases, and we also have a minimize player, or a player that wants to minimize, and a player that wants to maximize. So, okay, let's start with our algorithm. So when we call the Minimax function, the first thing we want to do is, oh, by the way, the function is going to receive a board, right? So in this case, let's say we send as parameter this board. Now, the first thing we want to do when we are doing the Minimax algorithm is check if we are on a terminal case. So in this case, we are not on a terminal case because there's no win and the board is not full, or there's not, well, a draw. Okay, so if the board is not on a terminal case, we want to loop through our board and we want to get all of the empty squares. So we already code that function, but what I mean is that we're gonna get, in this case, these 3 empty squares. And okay, let's say, as you can see in the second row, so this is the second row, I highlighted the player, or the next move. So from this board, from the first board to the second row, the player moving is the one of the circle, right? So is our minimize player. So what we want to do is actually tell that player, like, okay, for each empty square that we have here, try marking it and recursively call the function again until we reach a terminal case. So let's see what I mean. The first case is gonna be this one, this board on the left. So in this case, the minimize player put or marked a square, marked the first square with a circle. Okay, so we want to do the same. We want to check if we are on a terminal scenario, and we are not. So we're gonna do the same thing that we did the last time. We're gonna get all empty squares, and we want to do the same thing. So let's start with the one on the left. Now the one on the left actually has a terminal case. The terminal case, it's that the player that is maximizing, so the one with the crosses, actually, well, won. Now, what happens if we reach a terminal case? So there are 3 options, as I told you. Now, if player 1 wins, and remember, player 1 in this example is going to be the circle, and player 2 on this example is going to be, well, the cross. Now, if player 1 wins, remember, he wants to minimize. So we're going to return like a negative number. So it could be any negative number. I'm going to use -1 for this example. Now, if the cross of the maximizing player wins, we want to return a positive number. I'm going to use +1. And if we have a draw, so right here, if we have a draw, we're gonna return just 0 because neither of the players win. And this is a scenario that, although it's not like the best scenario for a player, it's not actually bad because you're managing to get a draw. So we're gonna return 0. Okay, so in this case, as the player that is maximizing, well, wins, we wanna return a 1, a +1. So I'm gonna put a +1 right here. Actually, let me put it, I'm gonna put it on green. So yeah, +1. So this board leads to an evaluation of +1. Now, okay, we now check this second branch. So we do the same thing. We check if we are on a terminal case scenario, and we're not. And we do the same thing for each empty square we have. And now we actually reach a terminal case scenario here, and is the minimizing player winning. So we're gonna return -1 for this. Now this board, this one right here, is gonna choose. So I want you to think of the player that is going to make the next move on this board. In this case, the minimizing player, right? So as you can see, the minimizing player was the one which made that move. Now, what does the minimized player wants? Well, he wants a negative score. So he's gonna choose from all the options, which in this case is only one option. He's gonna choose the lowest value. So in this case, -1. So this board returns or has an evaluation of -1 as well. Now, this is where things start to get interesting. So we're now on this board. This board, the player that is moving or the player that is marking a square on this board is going to be the one that's maximizing, the X player, the cross player. So the maximizing player wants to obviously maximize. So he's gonna choose the maximum score. So in this case, this +1. So this board leads to an evaluation of +1, right? Now we want to do the same thing for the other branches. I'm going to do it pretty quickly. We're not on a terminal case here. Now we want to check this one. This is not a terminal case. We want to check this one. This is actually a terminal case. Why? Because minimizing player wins. As minimizing player wins, he returns -1. Then this board is going to choose from all the scores the minimum score, in this case -1. And we do the same for this one on the right. It's not a terminal case, so we check the following one and we reach a terminal case, which leads to an evaluation of -1 as well. So I want you to see that from this level to the one that is down, the maximizing player is the one marking the next square. However, both options lead to an evaluation of -1. So this branch, it's not gonna be good for our maximizing players. So in other words, if the maximizing player reaches this branch or starts going through this path, he's going to lose. So, okay, this board returns an evaluation of -1. And we're gonna do pretty quickly the last board. So this is not a terminal case. This one is not a terminal case. We check this one. This is a terminal case because minimizing player wins. And as we know, it's going to return -1. Hence, this board returns -1. And now we want to check the next board. This is actually a terminal case because our maximizing player wins. So we return a +1. Now, remember, which player is the one doing the next move? in this case, the maximizing player. So he's gonna choose, well, obviously the +1 evaluation board. So this board leads to an evaluation of +1. And now we've reached the final step of our algorithm. So it's basically our main board, so this one right here, has now completed all the possible branches and all the possible combinations, and it has the 3 possible outputs. In this case, +1, -1, and +1. So again, what player is the one making the move from this level to the one that is down is gonna be the minimizing player. So what does a minimize player wants? He wants to minimize. So, and this is pretty cool, we know, or we can assume that the minimizing player is not gonna go for this board, neither for this board, hence for the boards below those, well, branches. So he's gonna choose, let me put in green, this board right here, or in other words, this path. And as this path, we already know that even though the maximizing player plays perfectly, the player that is going to win is going to be the minimizing player. So we get, let me put in green, we get that this main board has an evaluation of -1. So in other words, this is a board where the minimizing player, or the player with the circle, is going to win. And if you see it, it's pretty obvious. So the next player to move is the circle. So he basically can put the circle here. Why? Because he's blocking the maximizing player win. So he puts a circle here. Then it doesn't matter where the maximizing player puts the move or marks the square, the minimizing player is going to win with both options. So this is the first option, which is this case scenario right here, and the second option is let me see, it's gonna be the following. If he puts a circle here, maximizing blocks here, and he then puts a circle here, so he's gonna win also, which is this case scenario right here. So yeah, this is the Minimax algorithm. I hope it's a little bit more clear. I know it's quite confusing, but this will help us get a little bit more into it before we start coding it. So yeah, let's continue with the code and let's start coding our Minimax algorithm. Okay, so we're ready to start coding our AI class. So I'm gonna go ahead and code it just between the board and the game class. We are going to create our init method, and we're gonna receive self as parameter, level, which is gonna be by default level 0. So level 0 is basically a random AI, and level 1 is gonna be the Minimax AI, or the AI that uses Minimax algorithm. So we have a level and we have the player. The default is going to be 2. So inside of our init method, we put self.level equals level, and self.player equals player. So okay, I want to create the main function of the AI class that I'm gonna call it eval. So this eval function is going to receive, well, our self, and it's going to receive a board, and I'm gonna call it game, or actually main board. Now inside the function, we want to check if the level is 0. Well, I'm sorry, if the level is 0, so we can do a random choice, else, well, minimax algorithm choice. Okay, let's create this random choice function. So right here, go ahead and type dev. I'm gonna call it, let me see, R&D choice, or let's put it R&D. We're gonna receive self and a board, which is gonna be the main board. And this function is gonna be pretty simple. We want to, we'll create a new list called empty squares, and we're gonna access our board object dot get empty squares. So this is one of the functions that get empty squares. This is one of the functions that we coded before the Minimax explanation. So if you remember, is this function right here, and this function is gonna return, well, a list of all the empty squares, and by squares I mean just the row comma col, from a specific, well, board. In this case, this board that we're passing in the parameters. Okay, so we get all the empty squares, and then we're gonna use a random to choose a random index of this list and return that, well, that move or that square. So index is gonna be random dot rand range, and we wanna import random. So right here, import random, and we're gonna type random dot rand range. We're gonna start at 0 all the way to the length of our empty squares, and we wanna return empty squares in the position of the index. So here we are returning something, or some row and some column. Okay, so right here we want to do the following. We want to put move equals self dot R&D, and we're gonna pass our main board. So yeah, we are on an if statement. So if level is 0, we do the random choice, else we do the minimax algorithm choice that we're gonna code it in a while, and at the end of this if else statement, we wanna return our move. So remember, a move is just a row and a column. Okay, so I'm gonna test this random AI before we actually code the minimax. So let's see, what do we have to do? So inside the main loop, but outside the for loop, we want to type the following. So right here we want to check if the game mode is actually equal to AI, and the game player, so this is basically the next player to move, is actually equal to our AI player. We want to do the following. So first we want to update the screen. Why? Because let's suppose that the player marks a square. So before the AI marks another square, we want to first, draw this one. But we already draw it, but we want to update the screen, because remember, our update is at the end of the main loop. We want to just put another one right here. So Pygame displays.update. So this is going to update the screen. Okay, then we wanna do the AI methods. So we are gonna type row comma col. It's gonna be equal to the AI.evaluation function that we just created, and we want to pass. Oh, by the way, we need to create this object. So remember, we created inside of our game class this line of code that we have commented. Well, uncommented is basically just the self.ai or the AI object of the game, and it's actually a new AI. Okay, so, and also we need to like save it on a new variable, so I'm gonna put here AI is actually equal to the game.ai. So same thing as we did with our game board. Okay, so now we can access the AI dot evaluation for evaluation function, and we're gonna pass a main board. In this case, it will be our board. Okay, so remember the evaluation function is going to return a move, so a row and a column, and it depends if the level of the AI is random or it's actually intelligent. So we are saving that move into a variable or into two variables called row and col. And just before we do this, we basically want to do the same thing that we did with the human when he clicked a square. Now this, we are gonna make this a function because it's pretty much the same code. As you can see, like these 3 lines of code, it's actually the same as these ones. So yeah, we're doing a function for this, but later. But yeah, that's all. Like, we want to mark it with the random, in this case with the random row, with the random column, game player, that in this case is going to be the AI player. So actually we can put it AI player, it's the same. Then we want to draw the figure, and then we want to, well, get the next turn. So I'm gonna go to my game class, and instead of having a PvP game mode, I want to put an AI game mode in order to to make this if statement true. Okay, so I'm gonna run the file to see if it works. So I'm gonna click at the middle, and as you can see, the AI has randomly choose a square. So let's see. Okay, this is just luck. As you can see, the AI, as it's playing randomly, it was not able to block, and I'm gonna win right here. Okay, we also need to like somehow stop the game once we reach a terminal case, but we are going to do that later. But okay, we have our AI working. Now let's go ahead and code the Minimax algorithm. So I'm gonna first of all change the level to 1. So the default level is gonna be the Minimax. Like, I mean, the random game mode is cool, but we're here for the Minimax, right? So I'm gonna put it as default. Okay, so inside of our evaluation function, we're gonna code the following. We're gonna, I'm gonna call the Minimax. So this is a function that we haven't created. I'm gonna create it, Minimax, right here. So go ahead and type Minimax. We're gonna receive self. As I told you, we're gonna receive a board, which is the board that we are analyzing, and we're gonna receive a boolean, so true or false, which is going to be named maximizing. So if the player is maximizing or not, you'll see why. Okay, so our initial call is gonna be with the main board, and maximizing, we're gonna put false. So for in this code, or in this example, or in this tutorial, the AI is the player that is going to minimize. Okay, but you can put true. I think it should do the same thing. So yeah, in this case, our AI is going to minimize. So okay, let's start coding our Minimax function. So remember the explanation, the first thing that we wanna check are terminal cases or terminal case. So I'm gonna create a new variable called case. I'm gonna set it equal to our board dot I don't remember how we called that function. It's final state. So final state, remember, final state is going to return 0 if there is no win, 1 if player 1 wins, and 2 if player 2 wins. So okay, we create our case. This is gonna be a number between 0 and 2. So first, terminal case, player 1 wins. So if case is actually equal to 1, what do we want to return? Well, we want to return 1. Same example or same case that our example. Now, second terminal case is going to be player 2 wins. So if case is actually equal to 2, we want to return. Oh, wait a minute. Let me think about it. Oh, okay. So we are player 2. AI is player 2. And we are minimizing. Where is it? We are minimizing because we sent a false. Therefore, the player 2 must return a -1. Okay? So this is the AI. Now, the third and final case, it's going to be a draw. So it will be a leaf, a board dot is full. And we want to return a 0. And that's all. We have our terminal cases already coded. Now let's go ahead and code the algorithm. So we're gonna start by typing if maximizing, we're gonna do something, and if not maximizing, we're gonna do another thing. So the same thing, if the player is the maximizing player, we want to do something, and if it's the minimizing player, we want to do, well, another thing. I'm gonna start with this one, as this is the AI code. I mean, this if, or the code that is gonna be inside this if, it's gonna be, I mean, it's gonna be the same code as the one in this elif, but it's gonna change by some values and some small things, but it's pretty much the same code. But I want to do it in 2 different, well, blocks of code. So okay, let's start coding our not maximizing player. So okay, the first thing we want to do is create a new variable, and we're gonna call it minival. So this is the minimum evaluation that the not maximizing player or the minimizing player well, is getting from that specific board. In this case, we're gonna initialize it with a big number, so something like 10 or 100, like any number you want which is greater than 1 or 0 and -1. So it can be literally 2 and it will work. I'm gonna use 100. Now we're gonna create also a best move. We're gonna set it equal to none. And the third thing we want to do is get our empty squares. So remember, it will be board dot get it's get empty squares. So I'm gonna copy it from here. Get empty squares. Now we want to loop each empty square that is on this list or inside the list. So for let's put it for row comma call, because remember, inside of this list we just have a row comma call tuple. So for row comma call in empty squares, we want to do the following. First of all, we want to create a new board. I'm gonna call it temp board, and it's gonna be equal to copy. This is a model that we need to import. Copy.deep copy of our board. So we're basically copying the board. Why? Because we don't want to, well, affect directly our main board. We want to like test or go to the future, but well, testing it on other boards. So let me import the copy module. So yeah, we save the temp board. Then we are going to mark a square. So this is what I mean. We don't want to mark the square directly to our main board. We want to do it to a copy of it. So temp, it's temp board dot mark square, and mark square receives a row, so it will be row, this one, column, and it receives also a player, which in this case it will be our self dot player. So in other words, this is basically 2. Okay, once we mark the square, we want to again call the Minimax function. So this is the recursion part here, but in this case we're gonna send the temp board as our main board. Now maximizing, we're gonna put it equal to true, as we want to change player. Now it's gonna enter to this line of code, or if statement, I'm sorry, true. And okay, yeah, we don't need more params. Now the Minimax function is going to return 2 things, and you'll see. It's gonna return an evaluation, which is the evaluation that we have here, and it's also going to return a best move. So it's a tuple. It's going to be something like this: an evaluation and a best move. So go ahead and type on the terminal cases. The terminal cases, we just want the evaluation. So we can go ahead and put like the evaluation, comma, none, which is the move. So this is basically eval, comma, move. So right here also none, and right here also none. So okay, self.minimax is going to return eval and a move. But actually, in this line of code, we just want the evaluation. Why? Because the move is going to be this one. This is the move that is leading to this evaluation. But we need to access these, like the value that is returned in the Minimax. We need to access the 0 or the first position. So the 0 position is going to be the evaluation. So that's gonna be our val. Okay, so the next thing we want to do here is check if the evaluation in this case is actually less than our minival. So remember, our minival is initialized with a value of 100. So I mean, this is always for the first time, like when we check the first move, this is going to enter no matter what evaluation is, because evaluation can just be 0, -1, or 1, and like the 3 numbers are less than the minival. So if this is true, we want to put minival equals to eval, and we want to save our best move to be equal to, well, actually the row and col that lead to that evaluation, or to that minimum evaluation. Now at the end of this code, so once we've looped through all the possible moves or possible squares or empty squares, we want to return our minival with its respective best move, and that's it. This is the code. Basically, I'm gonna copy it and I'm gonna paste it inside the maximizing player, and this is gonna be pretty much the same, and we're done. We literally code an artificial intelligence. So I'm gonna paste it here. Now we want to change some things. So instead of minival, we're gonna put maxival. So make sure you change maxival here, maxival here, maxival here, and maxival here. And we want to put it -100. We want to initialize it as -100. Best move is gonna be none, Empty squares is going to be the same thing. This is going to be the same thing. Temp board is going to be the same. Mark square is different. We want to mark the square with the player number 1. And the evaluation is going to be the same, but we need to change here because now we want to tell the program or to tell the Minimax that the next move is gonna be by the minimizing player, so we put false. And now we check if eval is actually greater, so we need to change also this sign, is greater than the max eval. Well, we save eval into max eval, and we save our best move, which is row comma call, and we want to return the max eval and the best move. And I think we're done. So this is basically the Minimax algorithm. Let's see. Okay, I want to do something. So if you remember at the beginning of the video, I was printing something on the console. I want to do the same here. So, oh, okay, by the way, when we call this Minimax, this is going to return a move and I mean an evaluation and a move. So we're gonna put something like eval comma move equals with the Minimax. Now the evaluation, when we have a random AI, I'm gonna set it equal to, let me put it here, eval equals random. Like, this is not important, this is just to, I'll print it on console, and it's gonna be pretty cool. So we wanna print, I'm gonna put the F before these quotation marks. You'll see why. So we want to print something like AI has chosen to mark the square in pause. We're gonna put these brackets, we're gonna put move. That's why we are putting this F before the quotation marks, because it's gonna let us put variables inside these brackets, and it's gonna will parse the value into a string. So we pause move with an eval of eval, and that's it. So with an eval of eval. So yeah, we want to print that thing, and then we want to return the move, and that's all. I think we have the code like ready. So let's go to our main loop, and no, wait, let's go to our AI class. Yeah, level, make sure the level is equal to 1, player equal to 2. Make sure you have this Minimax function exactly as I have it. Make sure to, well, to call the Minimax with the minimizing player, and I think that's all. So okay, also make sure the game mode is AI, and I think, yeah, we're ready to run the file. So let's see if it works. I have the screen here, I click it, and look what happens. So the AI has chosen this square, and it says AI has chosen to mark the square in position 0, 0 with an evaluation of 0. So what does this mean? That at this point in the game, we are going to draw. Like, if I play a perfect game, we are going to draw. Why? Because we have an evaluation of 0. Now I'm gonna do a bad move. So I'm gonna put my cross here. You'll see this is a bad move. So I put it, and now AI says AI has chosen to mark the square in position 1, 0 with an evaluation of -1. So this is telling us, okay, bro, you're dead. You have no possibility against me. The board that I'm analyzing leads to an evaluation of -1, and that means that I'm gonna win no matter what. So you'll see, if I block here, he's gonna put here, and this is a genius move. Why? Because if I block here, the AI is gonna make this win, and if I block here, it's gonna make this one. So I'm gonna block this one, and as you can see, it says AI has chosen to mark the square in position 1,2 with an evaluation of -1. So yeah, it's pretty cool. I mean we did it. Now we're missing some basic things, but we've done the challenging part. So if you come through here, I know this video has been so long, but I want you to like feel proud, because this is not like easy code. Okay, it's been a long tutorial, but we're missing just a few things, so let's finish our game. Okay, let's see. The first thing I want to do is, as I told you, make this a function. So I'm gonna create inside of our game class, I'm gonna create a function called makeMove. So makeMove, we're gonna receive self, row, and col. And we wanna do, like inside here, we wanna do the following. We wanna do basically these three things. So I'm gonna copy those, I'm gonna paste it here. So we want to let's see, we want to make our self.mark square in row col with the self.player. We want to self.draw fig, and we want to self.next turn. Now we can delete this, and instead we just put game.makeMove row comma col. And like the useful thing about it is that we're gonna do the same for our AI. So you can see how we refactor those three lines of code. So pretty cool. So okay, let's see. The next thing I want to do is we need to be able to somehow change of game mode or change the AI level and all that. So remember Pygame events? We're gonna create some more, or not create, but we're gonna check some more events. So if the event, yeah, by the way, this is inside the this for loop. So if event dot type equals Pygame dot key down. So each time we press a key, so we want to do the following. The first one is going to be when we press the G key, we want to change game mode. So it will be if event dot key. So if the key that we pressed is actually equal to Pygame dot k underscore G, we want to put game dot change game mode. I think we haven't coded this function, so let's go ahead and code it right here. Def change game mode. So it's pretty easy. It's gonna be something like if self.game mode is PvP, well then self.game mode is AI, else self.game mode is PvP. So a pretty simple if else. I want to actually show you something. So we can convert these 4 lines of code into one. We can do the following. So self.game mode is gonna be equal to AI if the self.game mode is PvP, else it's going to be PvP. So this line of code is going to replace these 4 lines of code. So yeah, we changed the game mode with our G by pressing the G keys, the G key. Now we want to also change the level of the AI. So I'm gonna put 0. It's gonna be a random AI. So if event.key equals Pygame dot k underscore 0, we want to put AI dot level equals 0. and we're gonna do the same for the level 1. So when we press the number 1 key, we want to change the level to 1. Let's see what else. Okay, so let's try actually the one of the game mode. So by default we have the game mode against the AI. I'm gonna press the G key, so I press it. Now we should be able to play against another human. So as you can see, we can play another human against another human and against our AI in the same match, or in the same game. And the last event that I want to add is going to be a restart function. Well, not a restart function, but a restart event. So if event dot key equals Pygame dot k underscore r. I'm gonna do it with r. We're gonna put game dot reset. Now we need to create the reset function inside of our game class. So dev reset. We receive self as parameter, and we wanna basically just call our init method. So yeah, it's basically that simple. We're just calling. We're creating a new game object, or not creating a new game object, but we are like restarting all of our attributes to the default values, So that's the reset function. And after we reset our game, we wanna go ahead and type these. I'm gonna copy those 2 lines of code, and we wanna assign the game.board to board, and we wanna assign the game.ai to AI. Why? Because we've restarted our game, but however we haven't restarted our board. So this is a way of telling, okay, now the board is gonna be the new board that I recently reset it. So I don't know if I'm being clear, but this is going to reset the game. So I'm gonna show you. I'm going to play against the AI, so whatever. I'm gonna press the R key, and okay, we had a problem here. This is K in uppercase. We put it in lowercase. Okay, now it should work. I press R. Okay, it's not working. What is going on? Let's see. Pygame dot. Oh my god, I don't know what's going on here. Okay, guys, so I found the bug. It's actually pretty simple bug. So in show lines, in this method, we're going to paint the background first. So we're gonna do this screen.fill with our background color. Why? Because we need to somehow paint again our screen when we reset the game. And remember, show lines method is inside our init method. So once we restart our game, it's gonna call this, and it's gonna fill again the screen with the color. So this will be background, and I think it should work. Now it should work. Our restart function. Okay, so I'm playing against the AI. I'm gonna press the R key, and as you can see, we managed to reset the game. I'm gonna try to play again, and it's pretty cool. I'm now going to try to change the level of the AI. So if I press the number 0 key, it should be random. So let's say I put it here. Yeah. So as you can see, it says AI has chosen to mark the square in pos 2,2 with an evaluation of random. Pretty cool. And that's the only way that we are gonna be able to beat this unbeatable AI. This is a kind of hack. So yeah, pretty cool. I think we're missing just 2 more things and we are finished. Okay, we're gonna fix a a bug that we are having. I'm gonna show it to you. So when we run the file, I think this bug happens when we play against the AI. So make sure you are on AI game mode and try. Oh, I think I'm gonna lose. No, try not to lose. So this happens when the board is full, the game crashes, and this is because the AI is trying to find the next move from a full board. So what we want to do is, if you remember, we created inside of our game class, we created this running attribute. So we want to call our evaluation function just when the game is running. So game.running. Let me put end game.running. I want to copy this. I'm gonna put it right here because I want to have my let me set these. Okay, I want to have my human mark, the marking square of the human and the marking square of the AI close together. Okay, so human, we're gonna add this code also to the to this code. So we're gonna be able to make the move just when the game is running. So we add it here to the human code and here to the AI code. So okay, now once we make the move, we want to check if game is over. This is a function that we want to create. So if game is over, and right here is where we want to put, or we want to set the running attribute to false. And we want to do this also for the after we mark the square with the AI. So okay, let's go ahead and create this function. Is over, pretty simple function. Also is over self, and it's gonna be, we want to return if our board I don't remember the name of the function. So we're gonna access this final state function and also the is full function. So remember what final state function does: return 0 if there is no win, 1 if player 1 wins, 2 if player 2 wins. So let's see, let's go to our is over function. So we want to return if self.board dot final state, if this is actually different from 0, it means that we have a win, or if the self.board dot is full. So if either of these is true, we're gonna return true, and then we'll set the game.running to false, and we are going to avoid that bug that we were having. So let's see if it works. Try not to lose. Okay, so as you can see, the app doesn't crash, and we can reset it, so it's all good. And yeah, so pretty simple function. Now we're missing one more thing, which is obviously painting or drawing when a player wins. Now this code, it's a little bit long. We're gonna do it inside of our final state function inside of the board class. So yeah, the first thing we want to do is add a new parameter, and we're gonna put it show equals false as default. So show equals false. Now inside here if there's a win and we send show equals to true, or in other words, if we want to show the win, we're gonna do the following. So this is a vertical win. So let's type pygame .draw .line. So the surface is going to be screen, color is gonna be color. We're gonna create these in a while. Starting position, I'm gonna put it like this, like initial pause, and final position is gonna be final pause. And the width, I think we can use the line width. That should work. Okay, so let's create the color. So color is gonna be, and we're gonna do the same that we did, that I showed you, that we can turn an if else into one line of code. So we're gonna do color is gonna be circ color if any of these, I'm gonna use this one, is actually 2, else is gonna be cross color. Now let's code the initial position. So the initial position is gonna be the column times square size plus square size divided by 2. This is the initial x-axis, and the initial y will be, it will be like an offset. So think about it, we want a vertical line, so we want it to start like, I don't know, let's set the offset like 20 or something like that. And the final position is gonna be, let's see, it's gonna be, I think it's gonna be the same as the x, starting x, but it's gonna change for the y, so it's gonna be height minus the offset that we put here. So okay, we have our first line of code, our first drawing method. I'm gonna copy that, I'm gonna paste it into the one of the horizontal win. So again, if we want to show the win, color is gonna be circ color if, let's take this one, if this is equal to 2, else it will be the cross color, because remember circ color is the player 2. Initial position for a horizontal win is gonna be 20, is gonna start with 20 on the x. Y is gonna be row times square size plus square size divided by 2, and it's going to end at width minus 20 comma same y-axis. Okay, so we have the horizontal win drawing function. Now we want to do the diagonal. So this is long, as I told you, but it's not like hard, you know. Okay, so same thing inside the diagonal. Well, inside this if statement, we want to check if we want to draw, and again the color is gonna be circ color if, let's put this one, if this self.squares in 1 1, it's equal to 2, else cross color, initial position for the descending diagonal is going to be 20 comma 20, and it's gonna end at width minus 20 and height minus 20. We copy this, we paste it right here on our inside our ascending diagonal win. So yeah, color is gonna be the same. In the initial position of the ascending diagonal is gonna be 20 comma height minus 20, And final position is gonna be, let me think about it, it's ascending, so we want to end in the width minus 20 comma 20, and that's it. Now when, because we haven't put like show equals true, right? So where do we have to put this show equals true? So remember the function that we recently coded inside of our game class, the isOver function. We'll call it here. So return self.board final state show equals true. So we're just like telling if the game is over, we'll draw the win, you know, and that's it. I think this should work. Let me try it. I'm gonna play against the AI. I'm gonna let the AI beat me. I'm thinking how, okay, I'm gonna put it here. Okay, it draws the line. I'm gonna play against the another human to see if the line is working. Okay, this one is not working. Okay, we need to check that. Let's try another one against a human. This one is also not working. Okay, something is going on here. So a game that is over. It's over. Empty squares. Make move. Show equals true. Oh. Okay, I found the bug. We didn't draw the line actually. So just paste this line of code there and here as well. Yeah, it was pretty much that I wasn't drawing the line inside the descending and ascending diagonal. So I'm gonna try it against human versus human. Okay, this works. Let's try the diagonals. So this one, it works. Width here could be a little bit thicker. Can actually do it. Let's do it thicker. So let's put the cross width and cross width when it's diagonal. This is just a style design, so it's not important. I'm going to try and see. Okay, it's not changing. Which is the width that is? Yeah, cross width 20. Okay, I'm gonna leave it like that. Let's see. I want to check one more win. So right here. So I want it to be the same width as the cross. So cross width, what is going on? Oh, is that we put in on the, oh my god. Okay, yeah, my bad. I didn't put it here. Cross width. Now it should work. Change the game mode, and yeah, I like it. And we can reset it, and I think the code is we finished. So yeah, guys. Okay, we're missing one, well, not missing one thing, but I want to show you one thing. If we want the AI to start the game, we'll just make sure that the self.player is set to 2, because remember our AI by default has a AI player or a player attribute equal to 2. So this should make the AI start. Let's see. Yeah, it's thinking, and there we go. You'll see it always going to start here Why? Because I mean the optimal moves for the AI are gonna be the four corners. So there's no way the AI, like, I mean, it's pretty easy to lose here. Like if I put my X in a place that it's not the center, I'm gonna lose. You'll see. So it says automatically an evaluation of -1. That's because I'm gonna lose. I'm gonna make it start again. So as you can see, it will always choose this square, but you can do a random between the four corners and we'll randomly choose one of those. It's choosing this one because this is the first board that the AI knows that will return a good evaluation. Okay, so yeah, if I put it here, I'm also losing. So the only way you can actually manage to get a draw against the AI when it's starting, it's by putting it on the center. So like this. So yeah, pretty cool. I'm gonna let it as default, so self.player equals 1, and I think we finished. So if you find any bug, put it on the comments below. I will be able solving the bugs that you guys find. And I mean, that's all for this video. It was quite long. I'm gonna leave the GitHub code for this project on the description below for you guys to, well, if you want to see it. And yeah, I hope you liked this tutorial. It was pretty fun. I love working with AI and doing AI games. I'm also working on a tutorial on chess AI. So yeah, make sure to, well, leave a like, subscribe, and yeah, follow for more if you're liking this channel. So yeah guys, thanks for watching, and I'll see you in the next video.